Friction. Sample problem number 2. Two sleds are tied together with a rope, shown in figure 3. The coefficient of static friction between each sled and the snow is 0.22. A small child is sitting on sled 1 with a total mass of 27 kilograms, and a larger child sits on sled 2 with a total mass of 38 kilograms. An adult pulls on the sleds. What is the greatest horizontal force that the adult can exert on slide 1 without moving either slide? B. Calculate the magnitude of the tension in the rope between sleds 1 and 2 when the adult exerts this greatest horizontal force. Now let's look through the solution. The two sleds do not move when the adult pulls on sled 1. This means that the net force acting on the sleds is 0. And the applied force must be canceled by the total maximum force of static friction acting on the two sleds. To calculate the static friction, we must combine the two masses and treat the sleds then as one single object. So mass 1 plus mass 2 is 27 kilograms plus 38 kilograms, which is 65 kilograms. Now, as the coefficient of static friction is 0.22. So what's required to find the force of static friction, the maximum amount? So in our analysis, we know that μs equals Fs max divided by Fn. We can cross multiply and get the equation Fs max equals μs Fn equals, substituting in for Fn, mass Tg, we can then substitute in the values. 0.22 times 65 kilograms times 9.8 meters per second squared. So our force of static friction at the maximum amount is 140 newtons. The greatest horizontal force that the adult can exert on slide 1 without moving either slide 1 or 2 is 140 newtons forward. And here is our FBD for sled 2. Keep in mind that sled 2 does not move, which means that the net force is 0. In this case, the tension and the static friction acting on slide 2 will cancel. So M is 38 kilograms, μs is 0.22. We're required to find force of tension. Since force of tension is force of static max, calculate force of static max using μs equals force of static max over force N. Substitute in, again to the formula, we get 0.22 times 38 kilograms times 9.8 meters per second squared, which is 82 newtons. So the magnitude of the tension in the rope is 82 newtons. Now, on to sample problem number 3, coming in the next slide.